Hey there, it's Jason from Codemanship with another video diary entry. If you're enjoying these videos, please like and subscribe and ring the bell for notifications. So a conversation that I have regularly with client teams revolves around this idea of specialization. There is, I think, quite a widespread belief in software development that you can't be a programmer and a tester, or a programmer and a project manager, and so on and so forth. That it is not possible, it is not practical for an individual to understand all of the different disciplines of software development. And so I meet many teams who are very highly specialized, and that tends to result in a situation where people are throwing things over the wall to each other. So the architect is throwing things over the wall to the developers are throwing things over the wall to the testers, and so on and so forth. It's not a very efficient or practical way of working. And also, all of these disciplines are interrelated. That is, your understanding of testing will inform, for example, the way that you manage requirements analysis, and vice versa. That your understanding of architecture will change the way that you program. And if you program, that will change the way that you architect. So I've always been of the opinion that a software developer, as opposed to a programmer or a tester or a manager, these specialized roles, a software developer is someone who can, at some practical level, who understands all of those disciplines and is capable of doing all of them to some level of competence. Now I'm going to have to caveat that, and to start with, I'm going to show you a book. So this is where my opinion on this came from. Back in the 90s, in my sort of formative years in software development, I was introduced to this notion of software engineering. And I've got a book here, Software Engineering, A Practitioner's Approach by Roger S. Pressman, Esquire, but not Ted Theodore Logan, unfortunately. And this is a book that covers a whole wide range of topics in software engineering. Let's just go to the quick contents at a glance. So there's a chapter on the product and the process. There's a chapter on managing software projects, planning, risk management, scheduling, tracking, quality assurance, software configuration management, all that kind of stuff. That's quite a long chapter. Conventional methods for software engineering on analysis and design, testing, metrics, and so on. Object-oriented software engineering, so you're expected to know that as well. Again, analysis, design, testing, object-oriented systems, technical metrics for OO software, and then advanced topics in software engineering like formal methods, clean room software engineering, software reuse, re-engineering, client-server software, and so on and so forth. Now, the point I want to make about this book, as we just sort of flick through it, there's a lot in it. I do not get the impression that Roger S. Pressman wrote this book with the intention that different people would read different chapters. That if you were planning on being a tester, you would read the chapters on testing. That if you were planning, you might read them more carefully. If you were planning on being a project manager, you would read the chapter on project management, and so on and so forth. I think his intention was that if you are a software engineer, you're supposed to know all of this stuff. Maybe not totally in depth. There's some advanced topics that you might not know as much about, but you are supposed to understand management and planning and tracking and scheduling. You're supposed to understand architecture and design in whatever programming paradigm or system design paradigm you're using. You're supposed to understand testing. You're supposed to understand software configuration management, and so on and so forth. And there are things that are kind of missing from this chapter, particularly on the relation to human-computer interaction design. There's not much about that in there. So there's other stuff that you probably need to know as well. But what I got the impression of, the sort of takeaway I got from this book, was that this was a bit like my modern physics book when I was at university, in the sense that it's not supposed to be the only book about physics that you ever read. But it does contain enough information about all of the disciplines of modern physics, quantum mechanics, relativity, statistical mechanics, and complexity theory and chaos theory, and all those new branches of physics that have emerged in the last 100+ years. And this is a similar kind of a deal. That it's not intended to be the only book you read on software engineering, but it introduces you to all the key concepts in a fairly practical way. So you could just read that book and get a lot out of it, but then you need to go on and read more books. So there's my book on Object-Z, for example, for formal spec. I've actually done that. I've used this on real projects. I'm a bit weird like that. Practical Guide to Testing Object-Oriented Software. I've got a much bigger book on testing object-oriented systems by Robert Binder, but I'm actually using that as a monitor stand at the moment. It's a very big book. There's the book on clean room software engineering, and if I just look at my bookshelf, there's a ton of books on all kinds of things, on process, software processes, on configuration management, on architecture and design, on human-computer interaction design, usability heuristics like Jacob Nielsen's heuristics, usability testing, all kinds of things that I believed when I was sort of growing up as a software developer in the 90s that a software developer was supposed to know. And in that sense, a developer to me is a little bit like a building contractor. What is the difference between a programmer and a software developer? In my mind, it's quite clear. It's the same difference between a bricklayer and a builder. A bricklayer is supposed to know how to lay bricks. A builder is also supposed to know how to lay bricks, but they're also supposed to understand carpentry, architecture and design, electrical stuff, a whole bunch of other stuff they're supposed to know, and then all the health and safety and legal and the whole management process and estimating and all that kind of stuff. So there's a world of difference between being a bricklayer and being a builder. My dad was a builder for many years. I promise you, if you look at in his office, the amount of paperwork in there and books and stuff he's supposed to know, it's quite mind-boggling. So he went to college and he learned how to be a builder. He didn't learn how to be a bricklayer. So he had to learn a bunch of different disciplines. Now, he's not going to be the best bricklayer you've ever worked with. He's not going to be the best carpenter you've ever worked with. The stairs in his house are pretty interesting. But he knows enough about them, and he has a practical grasp of all of these disciplines, which means he can manage quite large projects, all the way from design through to seeing, from the conception stage all the way through to actually building the thing. So I've always been very clear in my mind, and that's kind of the journey that I took. Having said that, and this is where I caveat it, it's a journey that took a long time. It took many years, not just reading that one book, but reading many books and wearing those different hats, testing software, managing teams, and so on and so forth. So over the years, I've worn most of the hats in software development. And I think you have to. It's like riding a bicycle. You kind of have to try these things and do these things to really understand them, to have a grasp of them. And that's not a short journey. And I took a lot of my own time to do that. I did a lot of reading and experimentation at home on my own computer, for example, learning new programming languages or learning new techniques. Because I wasn't, as a software developer, I was very lucky for a couple of years to be essentially apprenticed and given that time. But once I left that job and became a contractor, generally didn't get given that time. I was expected to just hit the ground running. So I gave up evenings and weekends to learn how to do this stuff. Now, I personally believe that shouldn't have to be the case. I think it should be acknowledged by employers that being a software developer, as opposed to a programmer or a tester or a user experience designer, being a software developer requires a lot of learning over many years to get to a point where you really can wear all of those hats to some degree. And that means as a software developer, when I'm programming, I'm not just being informed by my understanding of code, my understanding of programming. I'm being informed by my understanding of requirements analysis, of architecture and design principles, my understanding of the whole product lifecycle, basically, through to maintenance and beyond, because I've worn all of those hats at some point or another. And I think it makes me a better programmer, in the same way that being a builder, I think, probably makes you a better bricklayer. Because you're not just focused on building the wall or whatever it is you're doing, you are actually thinking about the building and how everything fits together and how what you're doing fits in with what everyone else is doing. And the thing about software development is it's all connected. That's why there's so much communication is required, because it's all connected. And when you hire people and put them into these boxes, you create a ton more communication overhead, because a lot more communication needs to go on, and it's not very effective communication, because often requirements people and business analysts and testers and developers and managers and UX designers and operations people are often talking different languages. They're talking at cross purposes a lot of the time. So they have their own priorities and they don't understand other people's priorities. And so you get these unbalanced forces in your project and this massive communication overhead. And essentially you have to be throwing things over the wall. You know, designers throwing things over the wall to architects, throwing things over the wall to programmers, throwing things over the wall to testers, and so on and so forth. And so you tend to find in those teams where the roles are very highly sort of segregated, as it were, demarked, then they have to rely, for example, on documentation a lot more. They tend to produce a lot more documentation. There's also this idea, and I recorded a video about this quite recently, celebrating the achievements of small teams. When you have people in highly demarked roles, small teams are very difficult to achieve. It's much easier to have two good, well-rounded software developers doing all of it than to attempt to do something of the same size or complexity with a specialized UX designer and a specialized tester and a specialized database administrator and so on and so forth. So you tend up to have much bigger and more expensive teams, far less efficiency, there's far more waste in that way of working. Scott Ambler, the author of Agile Modeling, talked about generalizing specialists, software developers as generalizing specialists. So a database administrator is a software developer who specializes in databases. A UX designer is a software developer who specializes in user experience design, and so on and so forth. So they have their specialisms, and that's good, because there will always be someone who's devoted a lot more time to learning user experience design will be better at it than I am. But they are also informed by their practical understanding of the rest of the process. And that makes a big difference. So you can be a programmer and a tester. It just takes time. And employers, I'm talking direct, I'm looking down the camera directly at you now. You need to give people the time, because there are a lot of people in this world who would make great software developers, but they have lives that make it impossible really for them to fit this around their job. It needs to be, that learning process needs to be part of the job, and not just at the beginning, although probably more heavily at the beginning, not just at the beginning, for the rest of their career. So the idea of 20% time, you need to invest that time in your people. If you want small teams of highly skilled, very versatile software developers who will almost always give you the best value, then you need to invest some of that time and some of that money in getting them to that point. Okay, well, that's today's video diary entry. You must immediately go out and buy that book. No, don't. But I would certainly go take a look at the contents of the latest edition and have a little think about, well, what is the stuff that I'm supposed to know as a software developer? And then maybe shop around and see what other books are available to learn these different disciplines. So, hope you're doing well. Stay safe until the next time.